All right, in this video we're going to discuss power functions. And we're going to talk about what a power function is, and then we'll list some of the power functions that we already know and decide whether functions are power functions or not. And then we'll talk about their end behavior, and I'll do a couple of examples. So first of all, let's talk about what a power function is. A power function is of the form f of x is equal to k times x to the p. All right, where k is the coefficient and p is the exponent. Now let's look at a couple of functions that we have already talked about that are power functions. The first one is f of x is equal to 1. And we know that this is the constant function. And if you recall, its graph looks like this. So at 1, it just goes straight across. And it is a power function because this is of the form f of x is equal to 1 times x to the 0. Okay, because x to the 0 is 1. And so it can be written as a power function. So it is considered a power function. Then we have f of x is equal to x. And we talked about this. This is the identity function. And if you recall, it looks like a line that goes through the origin at a 45-degree angle. And it's a power function because it can be written of the form f of x is equal to 1 times x to the first. So the coefficient is 1 and the exponent is 1. Then we have f of x is equal to x squared, and that is our quadratic function. And it looks like this. And of course, 1 times x squared, the coefficient is 1, and the exponent is 2. Then we have f of x is equal to x cubed, which is the cubic function. And if you recall, it looks like a snake. And it can be written f of x is equal to 1 times x cubed, so my coefficient is 1, and my exponent is 3. And so it is also a cubic function. Then we have f of x is equal to 1 over x. And this is the reciprocal function. We haven't gone into a whole lot of detail with this one yet. But we have looked at it. And it is the boomerang, if you remember. And it can be written as f of x is equal to 1 times x to the minus 1. Because remember, when you have x to the minus 1, that means to take the reciprocal, and so that puts the x into the denominator. And so the reciprocal function is also a power function. Then if I have f of x is equal to 1 over x squared, it's the reciprocal squared function. And if you recall, it looks like the volcano. And again, it is a power function because it's 1 times x to the negative 2, because the negative exponent tells you to put it into the denominator. And so my coefficient is 1 and my exponent is negative 2. Then we have the square root function. F of x is equal to the square root of x. And let me write this down, square root function. And so it is half of a sideways parabola. And it's a power function because, if you recall, x to the 1/2. So if you have fractional exponents, that's the roots. So here the coefficient is 1 and the exponent is 1/2. And so it doesn't say that p has to be an integer or that k has to be an integer, although in all of these our leading coefficient is always 1. But for p, it can be a fraction as well. And so therefore we also have the function f of x is equal to the cubed root of x, and that's the cube root function. And if you recall, that one looks like the sideways snake. And it is a power function because this is f of x is equal to 1 times x to the 1/3. So remember, whatever this little index is right here is the denominator of your exponent. And so that is a listing of the power functions that we've looked at so far. Now notice that a lot of these are our toolkit functions, and so they should be fairly familiar to you because we've done a lot of work with them, but we'll continue to work with these toolkit functions because they are very important functions. All right, so now let's look at some functions and see, are they power functions or are they not power functions? So problem number 1 says f of x is equal to 2 to the x. Now this is not a power function because notice that in the power function the x is what is being raised to some power. Here 2 is being raised to the x power. So we're going to talk about these functions later, but this is not a power function. All right. Problem number 2 says f of x is equal to 2 times x squared times 4x to the 3rd. Now notice here I can simplify this because this is multiplication. I can multiply in any order I want. So this would be 2 times 4 is 8, and then x squared times x cubed is x to the 5th. So 2x is multiplied, 3 more x is multiplied, you add your exponents, you get x to the 5th. So notice that here my k, my coefficient, is 8, and my exponent is 5. And so it is a power function. Problem number 3 is f of x is equal to negative x to the 5th plus 5x cubed. Now, this one is not a power function because it has addition in it. So if I took just this part, that would be a power function, and just this part, that would be a power function, but I can't combine them because they're not like terms, and so this would be called a polynomial function, not a power function. All right, and then problem number 4 says h of x is equal to 2x to the 5th minus 1 over 3x squared plus x. And again, if we looked at pieces of this, that would be fine. But when you put it all together, this is actually a rational function. And so it is not a power function because I can't write it in a simplified form of k times x to the p. Now, let's look at the end behavior of power functions. All right, so if I have an even exponent, all right, and we've looked at f of x is equal to x squared, but it's the same thing if you do f of x is equal to x to the fourth or x to the sixth or any of those. So this is going to be a problem. Now, if I plotted points for f of x is equal to x to the fourth, what's going to happen is it's going to kind of flatten out a little bit more here and then go up faster. So it'll flatten out more and then go up faster. And then the same thing, but it's still kind of that parabola shaped. It looks a little bit more squared off at the bottom. And so anytime you have an even exponent, so you see 2, 4, if I had f of x is equal to x to the 6th or x to the 8th or any of those, it's going to be this parabola type shape. And so it's always going to, because remember, if you square negative numbers, you still get positive answers. Well, the same thing occurs if you if you raise a negative number to the fourth power, you still get positive answers. So you get positive answers over here and positive answers over here. Same thing if it's x to the 6th. Negative 1 to the 6 is equal to 1. Positive 1, because negative times negative is positive, times negative is positive, times is negative, times negative again is positive. Negative again is negative, and then negative again is positive. So if you raise it to an even power, what happens is you have the two negatives cancel with each other. And they do it over and over and over again. So x to the fourth, these two negatives cancel, and these two negatives cancel. So you get two positives, and that's positive. So with even exponents, you're always going to have this parabola type shape. Now notice on this one, no matter how I do it, it's always going to be going up, all right? So remember, this is where x goes towards negative infinity. This is where x goes towards infinity. Down here is where y goes to negative infinity. And up here is where y goes to infinity. Now, we don't call it y anymore, though. Remember, this is our x-axis, and this is our f of x axis. So the way that you say this is that as x goes towards negative infinity, what is y doing? Y is going up to positive infinity. So it says f of x goes to positive infinity. Now what happens when x gets really big? Well, again, the y goes up. So as x goes to infinity, f of x will also go towards infinity. So if I put in, say, 100, and I squared it, that would be 10,000. So as x gets, and if I put in negative 100, it would be positive 10,000. And then notice that as I get larger and larger absolute values, but smaller and smaller numbers, because I'm going negative here, I'm going to go up further and further. Same thing over here. As I plug in larger and larger numbers, I will get higher and higher values. So if I have an even exponent and my coefficient is positive, okay, so my coefficient is positive, then it's going to go up. Now, what if I have my k is negative? So let's just do f of x is equal to negative x squared. Well, we've already looked at this. What does the negative do? It reflects that parabola. And so again, my parabola is going to look like this. And if I have f of x is equal to negative x to the 4th. Again, it's going to kind of square off more and then go down again. And same thing for all of them. So again, let's look at what's happening with x, and then let's look at what's happening with f of x. So remember, negative infinity, the numbers get smaller and smaller here and bigger here, and then it goes positive here and then negative here. So this is positive infinity, negative infinity for the y-axis, or the f of x axis. And so here, when x goes towards negative infinity, notice that the y goes towards negative infinity. As the x goes towards positive infinity, then the y goes towards, again, they're both going down, so the y, or the f of x, goes towards negative infinity. So that's how you do the end behavior for even exponents. Now, when we looked at odd exponents, if I looked at f of x is equal to x cubed, well, we already saw that. This is a snake-looking thing. So it kind of looks like this. Right? If I made it f of x equals x to the 5th, well, again, it's going to kind of flatten off more here and then go up faster. And it'll kind of flatten off more here and go down faster. But it still has the same basic snake function. All right? And this is involved for any of them, f of x equals x to the 7th, as long as your exponent is an odd number, then it's going to look like a snake. Now again, let's look at our x. It goes towards negative infinity here and infinity here. And here's our f of x, and it goes towards infinity here and negative infinity here. So notice, as x approaches negative infinity, so when x goes this way, what's happening to the y? It's going down, because you see how it goes down. So when x goes towards negative infinity, y goes towards negative infinity. So f of x goes towards negative infinity. When x goes towards positive infinity, then notice that f of x is going up. And so f of x is approaching infinity. Now what happens if, and this always occurs if k is positive, if the number in front of the x is positive. Now what happens if it's negative? So if I have negative x to the 3rd, well again, remember, what does that negative do? It flips it over. And so it's going to look like this. And again, if I have negative x to the 5th and negative x to the 7th, or any odd exponent, I know that it's going to be flipped over, so it's going to be going down all the time. And so on this one, again, here's negative infinity, here's infinity, here's infinity, here's negative infinity. This one's for x, and this is for the y, or the f of x. So on this one, I'll say, when x goes towards negative infinity, what's happening to the y? It's going up. So as x approaches negative infinity, f of x goes towards infinity. As x approaches infinity, then f of x would approach negative infinity, because you see how it goes down. Okay, so let's look at a couple of examples. So problem number 1 says f of x is equal to 3x to the 8th. All right, So let's just see, what is this one going to be? Well, first you look and you say, is this going to be a parabola or a snake? So this one would be a parabola because it's an even exponent. So exponent is even, and so I'm looking either at this one or this one. And then I say, okay, is it turned over? Does it open downward or does it open upward? Well, this is a positive number, so it's going to be this here. So as x approaches infinity, as x approaches negative infinity, f of x would go to infinity, and as x approaches infinity, f of x also towards infinity. Okay. Problem number 2 says f of x is equal to negative 5x to the 9th. All right, so I look at this one and I say, first of all, I look at my exponent. It's an x to the 9th. So that tells me that it's a snake. Now the 5 doesn't really affect the end behavior, but the negative does, because it's an x to the 9th, and so I know that this one goes down. And so this one as x, so we're looking at one that goes down. So it's this one, so this is going to be your scenario. So as x approaches negative infinity, what's happening to the y? It's going up. And as x approaches infinity, what's happening to the y? It's going down. So you just look at it and you see, is it going up or is it going down? So that's how you work these problems. So on this section, all we're looking at is we're looking at power functions and we're looking at their end behavior.